back in lab, and I'm going to turn 9-fluorinone into fluorinol by doing a sodium borohydride reduction. So we'll start with the fluorinone. And then I'm going to add the sodium borohydride like we've seen in the lecture. And we're going to use methanol as our solvent. And what we're going to get is fluorinol. You see it's been reduced because this carbon had 0 hydrogens. Now it has a hydrogen. So it lost a bond to a more electronegative oxygen, gained a bond to the less electronegative hydrogen, less electronegative than oxygen. So that's a reduction. And you'll also get this sodium and then the boron with the 4-methoxys on it. This is the main thing we're concerned about. And in the reaction, it has a long mechanism, but the key step is the first one. The ketone gets attacked by, by the borohydride. Borohydride looks like this. It's an unusual molecule in that the hydrogen is the more electronegative atom here, which isn't normally the case. So it acts as a hydride, a strong nucleophile, attacks the carbonyl carbon, which is a weak nucleophile, but as long as one is strong, we're good. And then we get this. That boron is never happy. I don't want a negative charge. So that's the hydride onto the ketone, which is now negative. Reduced, and you think, okay, we're pretty much there, right? We just need to protonate this, but there's a lot more. There's many more steps to this mechanism. It's online in our mechanism database, because you remember now the boron, who's never happy, says, I don't have an octet. So the oxygen can add to this, and then it could give up another hydride, another oxygen, not the oxygen, the other alkoxide oxygen. And so yeah, and then at the end, the way the reaction is going to be quenched actually is when it's added to the TLC plate. The TLC plate is a little bit acidic. Remember, TLC is our TLC plates we're using are silica. They're slightly acidic. And you can think of it as this silica is what adds the hydrogen to the alkoxide. And then that hydrogen gets replaced by methanol, or the methanol protonates this. Either way, the reaction is quenched right when we spot it on the TLC plate. So then, right when we spot it on the TLC plate, the reaction's done. And all the sodium borohydride, the excess sodium borohydride, gets quenched. So the reaction stops immediately when we spot it on the TLC plate. But there's many more steps here before we get to that. I just want you to understand that once I take a sample of the reaction in my capillary tube and I spot it on the TLC plate, it stops the reaction. And my TLC plates, I already prepared them. And I just thought of something. It's a good idea when you prepare your TLC plates before you spot them to check them to make sure nothing's splattered on them. So let's look really quick. I'm gonna go short wavelength to 54 nanometers. When I look in there, they look pretty good. I do see maybe a little spot on one of them at the top by my initials, but they're fine. They look clean enough. So that's good. And I'll show you how I labeled them. I want to grab them out carefully, try not to touch the silica, the matte side. So I've got remember, silica on this side, and the shiny side is just a plastic backing. So I've already written on the silica side lightly with pencil, and I've put my initials up top and the date, and now down below I'm going to have at that first position the fluorinone, this as my initial starting material. I don't have any fluorinol. If you remember last time I couldn't find it, but that's okay, we're going to make fluorinol now. So I have the fluorinone, and then I'm going to spot the reaction at 0 seconds. The way that will work is it'll be before I've added sodium borohydride. What I'm going to do is over here in this little 5 ml conical vial, twist it around so you can see the graduations. Yeah, this is a 5 ml conical vial I have on this stir plate. It's hard to read. There you go. This is a 5 ml conical vial. See how it goes to 4 milliliters? I don't understand why they do that, but this is a 5 ml. Because it can go up above 4 to 5, but it doesn't have a graduation for 5. I don't get it. But anyways, this is what we're going to use to run our reaction. It has this thing called a spin vane in there. I'll show you what that is. It's this Teflon coated magnet in a triangular shape. So the part that sticks out, there's a magnet in there. And you put it in the conical vial, which we call conical because it kind of cones down at the bottom. See how it's cone-ish there? Comes down inside. So you put it inside of here with the most acute angle pointing down. And the reason why is it'll then sit on that sharp acute angle, and when I put it on the stir plate, it can be stirred. I'll show you what I mean. I'm going to clamp it down first, make sure it doesn't go anywhere. Then I'm going to come over here and I'm going to look at my stir plate. There's stir and there's heat. I don't want to heat this reaction. It doesn't need heat. I'm just going to stir it. So I'll turn the stir plate on. When you turn it on, just turn it on like the smallest bit at first and you might not see anything happen. Oh, wait, nope, it just took a little while to get going. It's starting to spin a little bit. Isn't that cool? So what's happening is underneath this, the heat plate, the plate of the hot plate, which isn't being heated now, there's a magnet. Let's see if we can see it, and it's spinning. See, oh yeah, there it is. So you can barely see it. There's a magnet under there spinning. And since that magnet's spinning, the magnetic stir bar will spin too. And that'll stir our solution for us. And you want to stir the solution just enough, not too much. A lot of times students do this initially. They'll turn the stir plate to full blast. And then what will happen is the magnet just can't quite catch. This one's actually doing okay. But a lot of times it'll just kind of jiggle, which actually might be enough to stir the solution, but if you want it to stir nice, you just kind of start slow, get it going, and then go back. Sometimes the stir bar just needs to break that coefficient of kinetic friction to start, and then it'll keep going, and you can slow it down. All right, so you know how that works. So now, I lost my train of thought. So what I was going to say was we're going to have the reaction taking place in here. First, I'm going to add just the fluorinone and the methanol, just those two. So when I have fluorinone and methanol, no reaction takes place. The fluorinone just dissolves in the methanol. So that'll be my solution. And I'll take a capillary tube. I'll dip into this. Where are my capillary tubes? Oh, here they are. These are the capillary tubes I pulled last time. I'll dip my capillary tube in the reaction. It's not a reaction yet, it's just fluorinol and methanol. And I'll spot that at 0 seconds. Then I will break off the tip. Then I will set a timer. I got a timer over here. I'll set this timer to start counting down once I add the sodium borohydride. Immediately when I add the sodium borohydride, it'll start reducing the ketone. So when I add the sodium borohydride, I hit start timer, and then after 10 seconds, after I've added 10 seconds after I've added sodium borohydride, started the reaction, I'll spot right on the 10-second mark. And then at 25 seconds, I'll spot here, 45, 65, and then I go over to the new TLC plate, 85, 105, 125, and I'm leaving those two blank. I'm not sure how long I'll wait for those ones. I'll see how it looks. Okay, so there's a little bit more about that. When you spot it, if you want to be accurate with the time, more accurate with the time, what you want to do is you can stick, let's say I want to do the time for 10 seconds, right? So I add the sodium borohydride, start the timer, and then when it's at about 5 seconds, I can dip my capillary tube into it, and now it's 6 seconds, 7 seconds. What's going on is that this capillary tube is a glass tube, kind of like our glass conical vial. So the solution that I draw up into it, it's still continuing to react, even when it's taken away from the conical vial. So at 5 seconds, I pull some of the reacting solution out, 6 seconds, 7 seconds, 8 seconds. And then while I'm actually, before I spot it, I have some paper towel, 8 seconds, 7 seconds. I'm draining out most of it. 9 seconds, and then I'll spot 10 seconds. I'll spot it. I'll hit the TLC plate when it's 10 seconds, break off that tip, then come on over, and at that point, even at like 15 seconds, I can still draw the solution out at that point. I don't have to wait until right before 25 seconds, because it'll still react in the capillary tube. So then, but then after like at 20 seconds, I'm draining at 21, 22, 23, 24, 25, I spot it. So yeah, that's the timing of it. Let me see if I can do this timing, videoing and the reaction all at once. I think I can. Hold on. Okay, I'm over at the scale. I'm gonna weigh my fluorinone into my conical vial. And let me tare it first. Well, I didn't have to tare it until I added the conical vial. Add the conical vial first. Let that settle. Tare that. It's close enough, but that's okay. All right, there we go. Now I will add the fluorinone. I'm aiming for 0.2 grams of fluorinone, approximately. So let's do it. Fluorinone, remember, is that yellow, it's the yellow solid of these compounds. Let's see if that's 0.2 grams right there. 0.03. Still got a ways to go. Now we have an idea of how much that is, so 0.2 will look like. And I'm doing the additions outside the scale, as always. And I put that in, that's at 0.11, about halfway there. Close enough. About 0.198687. 0.1988. Okay, there's my yellow fluorinone solid. And I'm going to clamp it on the stir plate again. And I'm going to fill it with methanol to a volume of about 4 milliliters. And before I do that, I took out my spin vane. I'll add that back in. So here's the spin vane, pointy side down, and get some methanol. I'll just pipette it in, it's only 4 milliliters. So I'll draw some up, push it out, draw some up, push it out so it doesn't shoot all over the place on me. Okay, it's looking pretty good, it's not too drippy. Come on over, 1 pipette full. Looks like I'm about milliliter. At about a milliliter. 2 pipettes full. 3, 4. That got us there. Yeah, that's about right. Maybe it's a tad under 4 milliliters. Good enough, just the solvent. So at this point, it's not all dissolved, but let me stir it. I'll get it dissolved, I bet. I'll turn on the stir. Make sure I'm turning on the stir, not the heat. I often have students accidentally heat this reaction, turning the wrong knob. So it's stirring. Let's see if it dissolves at all. A lot of times when you stir, you can get a nice like whirlpool vortex in there. It looks kind of nice. Let's see how ours looks. Looking kind of nice. It's smaller volume, so it doesn't quite give you as cool a vortex. I'll try to speed it up, see if I can get a little more of a vortex. Looks like there's a little bit of solid up along the walls of the solution. I could try to get that down in solution or just live with it. I think I'll just live with it. Let's stop the stirring, see if it looks like it's dissolved. Looks pretty good. It's hard to say, huh? Even for me live, it's hard to say whether it's all dissolved, but I think most of it is. And even if it's not all dissolved, I think it'll be fine because we will, you know what though? I'm gonna add some more solvent. Let me add a little bit more. This one, I think think it'll be fine with a little more solvent, and then I can wash down the walls too. So I'm going to get another pipette full. Wash down the walls a little better. Yeah, so it's a little over 4 milliliters. No graduation, of course, but I'm going to estimate. Let me get that in focus. I'm going to estimate that's at about 4.3 centimeters. Milliliters. I'll start stirring again. Okay, so now I will prepare my sodium borohydride. Now I'm going to weigh out my sodium borohydride, and I'll do it, this is sodium borohydride. I'll do it on wax paper this time. I'll take the wax paper, well actually why wax paper instead of just scratch paper like before? Sometimes the sodium borohydride can kind of stick to paper, so regular paper, so I'll just use wax paper, it won't stick as well. I'm going to first fold it in half so that I can easily pour it into the reaction once I've weighed it out. So there we go, one handful. So I'm going to put my sodium borohydride in here, and then I'm going to pour this into the methanol fluorinone solution to start the reaction. So first though, I'll put this wax paper in the scale, and I'll make sure my wax paper is not touching the edge, it's only on the pan. So like if I put it like this, it's not going to give me an accurate reading because it's resting on there. Only on the pan. It's looking good. And then I'll zero it. And I'm looking to add about 0.022 grams, which is about 22 milligrams. So let's see if I can get close to that. Okay, let's see what that weighs first. Not quite there, almost 16 milligrams, so about 22. I don't want to take too long with this because this sodium borohydride is hygroscopic to pick up moisture from the air. I'll go with that. So so it's like 20.2 milligrams. Okay, I've got this going. Going to see if I could start my timer and add everything and do it all at the same time. But usually I have you do this in pairs, so it helps you not have such a difficult time timing it. But that's okay. If there's some error in this, it's fine too. It's approximate. Okay, so put my phone down here, so that'll make it easier. So now I'm going to add my sodium borohydride, and right as I add it, I'll start my timer on the computer. So here we go, get set. Okay, it's in, start, oh, start. My timing's off by about a second, that's okay. Now I have to get my capillary tube, and oh, you can see it's bubbling a little bit, huh? Go. And now I'm going to stick my capillary tube in here. I've got this solution, and oh, I'm already past my time. That's okay. I'm going to go off the time that I have. So I'm going to spot, drain most of it out, and then spot it on, oh, I didn't do 0 seconds. At 10 seconds. Boom, that was actually 33 seconds. I'm going to have to adjust my thing. Yeah, this was not as easy as I thought to do alone, but that's okay. So that first spot was 33 seconds. I'll write it on here. 33 seconds was the first one. And then let me just get another one, and I'll just tell you what time it says. And the 33, actually, I'm going to call that 34 because I started the timer a little late. So let's say 34 seconds, and then let me go back into my solution again. Draw some up. you can see it pretty good now, huh? The yellow. And then I'm going to bring my camera over this way to my TLC plate area. Spot most of that out. And now where it says 25 seconds, it's not 25 seconds. I'll tell you what it is when I spot it. So I could have just left these blank cut. Okay. Boom. That was at minute 35. So minute 36. 1 minute 36 seconds. Okay, next up. Next one, I'm sticking into my solution. I got some more. Got some more here. I'm going to drain it. I'm going to spot it on the 10, the 25, the 45 area. And the 45 area will be at 2 minutes 11 seconds. Okay. And then I'll spot the 65-second area as, let me go drain, drain, drain. Let me zoom in so you can see the spot. And when I spot it here, 1, 2, yeah, got it. That was at 2 minutes 38 seconds. Okay, and I'm gotta get a new capillary tube. I broke that one down too much. Now I'll go back and I'll do the next one. It says 85 seconds. Let's see what it actually is. I'll drain, 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 and let's spot it. I have it on camera. There it is. Pretty good, huh? Let me move it here. Okay. So now when I spot it, 1, 2, boom. That was at 3 minutes, 20 seconds. So this is my second plate. Okay. Now I just broke off that end. I broke off the piece, remember, that had the solution. So now I have a fresh piece of capillary, fresh amount of capillary tube. Let's go again. At the 105 mark will be there, and that's at 3 minutes 51 seconds. And actually, we have a visual clue for this reaction as well. Remember, the fluorinone started out yellow. It's currently still yellow. So what that tells me, it's lighter yellow though, huh? So it looks like the fluorinone is yellow. So the fluorinone is yellow. And when it's reduced to fluorinol, that's a white solid. So the yellow color should go away from the solution as it reacts. So that's a good sign. And once all this fluorinone's gone, then it should be a colorless solution. So it's getting there, huh? I'm gonna do a little bit more and then we're gonna do something else. Let's go, let's see, where is our TLC plate? There we go. I'm gonna next spot the, let me make sure. I forget where I'm at because I didn't, the numbering's all off. This experiment's gonna go well though still. I just took my TLC plate over to the UV light box. The last one was 105, yeah. I'm gonna do a 125 and then I'll tell you what we're gonna do next. So let me go into here. Drain, 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 drain. And then I'm going to spot at 125. There, and that was at 5 minutes, 26 seconds. So my guess on this experiment is that the reaction is stopped. I believe what's going on is that the sodium borohydride I've added to this reaction, it wasn't very pure. So even though if I take the massive sodium borohydride that I added and I can figure out moles, it'll seem like I have an excess of sodium borohydride. I don't think I did because that sodium borohydride I used was kind of old. It's probably hydrated and I was weighing out water as well. So I'm gonna go with that I didn't have quite enough sodium borohydride for this reaction. And I'm gonna add a little bit more and then take the TLC of that. So let's Let's go get some more sodium borohydride. I've got a new piece of wax paper. I'm going to put that on the scale and zero it. Should be pretty close to the other piece of wax paper. Pretty close, huh? Zero it. Okay, get my sodium borohydride again. And I'm going to add about the same amount I added the first time. Let's see. Make sure I get this reaction done. I want this reaction to go to completion. Okay, so that should be plenty, I think. Let's see how much that is. Not quite as much as I added initially, but I think this is going to do it. I'm adding now another 12.2 milligrams. So as I was walking over with my 12.2 milligrams of sodium borohydride, some spilled. So I came back and added more. Now I'm actually adding for the second aliquot for 17.4 milligrams more sodium borohydride. Okay, I'm going to add more sodium borohydride. This is at about almost 10 minutes in. I'll tell you the time when I actually get it in there. So boom. It's in at 9 minutes 56 seconds. So 9 minutes 56 seconds, added 17-ish milligrams more sodium borohydride. Okay. So I'm going to give that a little time to react, and then I will spot that on the TLC plate too. I'll do it at like 11 minutes and 12 minutes, say. Let's see if that works. Get my capillary tube ready. Got it. I think the bubbling, my guess is the bubbling is the maybe the reaction's exothermic, and it's making the methanol bubble up a little bit. Could be hydrogen gas, but I don't think you make much hydrogen gas in this reaction. Okay, actually, I was talking, I didn't keep track of the time well. Let's see, I'll tell you what time. It won't be exactly 11 minutes. Alright, so where am I? Right there. So where it says 11 minutes, I'm going to spot it at about 11 and a half minutes. So let me do that. Now, got it, 11 minutes, 31 seconds. Okay, so I'll wait a little bit longer now, and I'll do a final spot. And then something I forgot, this experiment, man. I didn't do the 0 seconds spot, huh? The 0 second spot is just the 0 second spot, that's just, I was supposed to spot it before I added any sodium borohydride, and that's just when I have methanol and fluorinone, but I can make that up myself. I'll put a little methanol in some fluorinone and spot it there. And then the fluorinone was going to be basically methanol fluorinone, or actually I'll do the own one all by itself. I'll do it fluorinone with methylene chloride, so it'll be a little different solvent, a little bit different. All right, let me take my last one here. I've got some out of the reaction. Oh, that one didn't break very good. I want to break this one again and do it again. So draw out of my reaction. Okay, drain it off, and I'm going to spot at the 12-minute mark, but where I have it labeled as 12, but it is actually 12:55. Okay, that's the final one, and so there's my data, timing data, and I'll put it in the Google Doc in a more readable, understandable order. And now I will let this stir a little bit while I get the other spots ready. So I added a pinch of fluorinone to a test tube, and then I added some methylene chloride. It's maybe like a half a milliliter of methylene chloride in here. And I'm gonna spot this as my fluorinone standard spot. So I'm gonna get my capillary tube, stick that all the way down and into the solution. And now I've drained out most of it onto a paper towel. Let me get my zoom in on this correctly. So I'm going to be spotting on the very first own spot. That's the spot that will be for the fluorinone dissolved in, this thing looks a little weird, okay. There we go. That's the fluorinone dissolved in methylene chloride. I'm gonna do that for both TLC plates. That's gonna be a standard for both. Did that go blurry on you guys? Okay, here it is now, fluorinone. Got it? Okay, those two are spotted. Next, I want to spot the fluorinone that was dissolved in methanol. That'll count as my ×0 spot. So here it is, fluorinone dissolved in methanol. Okay, stick my capillary tube down in there. Get the solution out, and first drain it off, most of it, onto a paper towel. Okay, and then I'll spot that at ×0. There we go. All right, so a bumpy road, but it's gonna work. Let's put this in the UV lamp box before we run it and see how it looks. Okay, here we are. I've got the 254 nanometers. There it is, it looks good. So we have the fluorinone spot. That's the one that was fluorinone dissolved in methylene chloride. 0 seconds is the fluorinone in methanol. And then I've got the first spot was not at 10 seconds, but at 34 seconds and blah, blah, blah. But they all look good. That's on the first TLC plate. Let's check the second one. Okay, here's the second TLC plate. The own one is for fluorinone and methylene chloride, but the methylene chloride just evaporates away. So, okay, and then we have the other time spots. Well, now we'll run them. So what solvent should we run these in? Do we have to run like, a few different solvents to figure out what would be best to separate the fluorinone from the fluorinol? I don't think so. The reason why is we did the first part of this experiment was fluorinone and fluorine, and they separated out well with methylene chloride as an eluent. So let's just make up a chamber of methylene chloride. That should work. I'm testing out if I can run 2 TLC plates at once in the one methylene chloride chamber. It looks like I can. I don't have any methylene chloride in there yet, but what I did is I just tore back my wick a little bit on the sides, and now I can have these 2 TLC plates in there not touching themselves and not touching the wick, so I can even move this guy over a little bit. Yeah, plenty of room for 2, so let's do this. I'll take those out, and then I'll fill up the chamber with methylene chloride, and you can see I tore off the sides of the wick just to give me a little more room. And let's put the methylene chloride in. So I'll draw up some methylene chloride and just start shooting it in there. Getting the wick wet. And I just want to coat the bottom of the chamber. I don't need to go too high up with this because it needs to be below the level of my spots. I can check it on the outside actually. Let's see if I did a good job. So if I have this in there, yeah, it looks like it's going to be below the level of the spots to start. I think it looks good. I think you get a parallax error, but from my visual, it looks good. Okay, let me set these in. Set the first one in here. Yep, it's below. The spots are above the solvent. Set the next one in right here. There we go, it looks good. And now I just need to cap it with a watch glass. Before I do, I can give you a closer look at it. See, the solvent's now above the spots, but it started below. It's rising up. Let's cover it and let it go. We'll pull it out and see what the results look like. While that's going, I can show you our reaction over here. It's a lighter yellow, I think. And so I think there's definitely some fluorinone left, but it might be very, very little amount. It might be like less than 1% left of the fluorinone, because the fluorinone, it's got a very bright yellow color, so barely any of it gives you a lot of color. Like an indicator used in a titration, it's a very colorful molecule. Now I will take my TLC plates out and see how they look. So remember, when you pull them out, you want to immediately label the solvent front. Got that one. Shake, 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 shake. Shake it like a Polaroid picture. Okay. Oh, and then drop it. And then this one. Mark that solvent front right away. Shake, 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 shake. Okay. And the first one here, I could put this in the UV lamp to see how it looks. .254 nanometers. Oh yeah, look at that. So what do we got going on here? So that first spot, the top spot, is the fluorinone by itself. That was dissolved in methylene chloride. And then the other spots are at different times. They're at like 9 minutes 56 seconds, 11 minutes 31 seconds, 12 minutes 55 seconds. So those show the lower spot. So what would be the lower spot between fluorinone and fluorinol? The fluorinol would be the lower spot because it's got the alcohol. It's more polar. It sticks to the polar stationary phase more. So it looks like the reaction's gone to completion at about third time in. 1, 2, 3, about 5 minutes, 26 seconds. It was already done. And that's before I added the extra sodium borohydride, so I probably didn't even need to add that. Let's look at the first TLC plate, see what that one's telling us. Okay, so for this one, this time I'm looking at the lower TLC plate, and that lower TLC plate is telling me initially the fluorinone dissolved in methylene chloride, the top spot on this plate, the top spot, that's showing just fluorinone. Then at 0 seconds, still fluorinone. It was just fluorinone dissolved in methanol. We're just checking to see if the reaction solvent did anything to that TLC RF. It didn't. And then at the first spot was 34 seconds. You can see we have both fluorinone up top and fluorinol down below. And at the next spot, which is at 1 minute 36 seconds, still fluorinone, fluorinol. 2 minutes 11 seconds, we've got both of them. But then by the last spot on this TLC plate, at 2 minutes 38 seconds, we're seeing the fluorinone up top getting smaller and smaller. It's starting to be completely reacted. So very good. It came out great, even though I fumbled through it. It worked out well. So now what I'll do is I'll circle all these with a pencil and take the data for us. Okay, I'm coming over to get an iodine chamber. So here is an iodine chamber. It says iodine chamber. And that purple solid on the bottom there, that's iodine, that's I2. So iodine is a halogen, and you can see on the periodic table, it's one of the heavier halogens. So we have fluorine up top. So F2 is a gas when it's elemental fluorine, very reactive gas. Cl2, a gas again, very reactive. Br2, a gas again, reactive, but not as reactive as chlorine. And then I2 is next. It's not a gas, it's a solid. It gets heavier. But it's a solid that has got a lot of gas vapor pressure. So it's a solid that will sublime. So it goes directly from that purple solid to a purple gas. Do you see how this looks kind of purple inside of here? So that's iodine gas in there. Okay, so the reason why I brought this iodine chamber over is because I want to show you another way to develop or visualize a TLC plate. So far, we've only used the ultraviolet light box, right? But now we can do it another way. If you take your TLC plates and you put them in the iodine chamber for a little while, what happens is the iodine gas, because the iodine solid sublimes directly from a solid and it goes to a gas. It doesn't melt to a liquid first. It goes solid to gas, like dry ice, carbon dioxide. So that iodine gas is in the chamber. It can bind to your molecule. It'll bind to pi bonds temporarily, and when it does, it gives it color. So you could visualize spots that way for molecules, say that some molecules do not show up under the ultraviolet. They just don't have conjugated pi bonding or something else that absorbs the light. So you have to figure out another way to visualize your TLC plate. And this is another easy thing you can do. You just open up the iodine chamber and put your TLC plate in there. And stick it in there. It doesn't matter which way it goes, but I want it to go this way. There we go. And then I'll stick them both in there, why not? So I've got my 2 TLC plates in the iodine chamber. I'm going to cap it again and let those iodine I2 molecules, gaseous I2 molecules, stick to my TLC plate. And the I2 will stick to certain molecules but not others, so some of the molecules will turn purple, some won't. So it's also, sometimes if you have 2 molecules with the same RF under UV, you can put them in an I2 chamber and one of them will be developed by the I2 and the other one won't, so you'll know they're different molecules. And so this, visualizing your TLC plate with ultraviolet and with iodine, that's 2 of many different techniques. There's other ones where you have like a solution that's got an oxidizer in it and you put the TLC plate in there, and then when you take it out, molecules like alcohols that can be oxidized turn a certain color. You might turn green or something. And there's other ones where you can even see, like if you have a ketone, it's maybe orange. And it's pretty cool. You have different developments you can use. So while we're waiting for the I2 chamber, let's go over to our reaction. We're gonna actually isolate the fluorinol we made. Remember, we started with fluorinone, and by TLC it looks like pretty much all the fluorinone's gone, and we just have fluorinol. Let's isolate that. The way we'll do that is I'll stop the stirring, and I'm gonna pipette my reaction solution into this 25 milliliter Erlenmeyer, which I've labeled, actually it's got an old label, methanol, on the white label, which is okay. This will have methanol, but yeah, no meth. Yeah, I'll keep that. It has methanol. It will have methanol and the fluorinol, so that's good. All right, so let me pipette that over. So I'll suck up some of my reaction, push it back out, suck it back up, and put it into my. It's dripping a little bit, but I got it. Okay. Since this is such a small scale reaction in the microscale glassware, this conical vial, I'm going to use a pipette to get it out. It's better than pouring, I think. And this will be easy to leave it'll be easy for me to leave the stir bar behind. Now I'm going to decide, do I want to rinse that with a little methanol? It looks like I've got some fluorinol solid on the side of the glass and fluorinone. So if I want to get more fluorinone out, see the white solid is fluorinol, I'm guessing, and then the yellow is fluorinone. I'll just leave it. Let's see what I got here. So my procedure now says to add some water to this. Now I'm going to add 1 milliliter of deionized water to my reaction. I got a 10 milliliter graduated cylinder, so I'll fill the meniscus up to there, to the 1 milliliter mark. Do my best here. Let's see, almost. I think that's pretty good. Let's see if you agree. Does that look to be about 1 milliliter? It's hard to read how the one. That's the one, yeah, that's about 1 milliliter. And I'm gonna pour that into my reaction, and when I do that, I'm going to have no longer just methanol as my solution. I'm going to have methanol and water. And methanol and water are miscible, remember, meaning that you can dissolve in like any proportion of water and methanol will dissolve in each other. So now I have this new solvent. It's not just methanol, it's methanol and water. And what's more polar, methanol or water? Water. So if water is more polar, methanol is polar but less polar. The mixture of methanol and water would be like in between. So I've made my solution a little more polar by adding the milliliter of water. Ooh, I almost knocked this over. And look what happened. My product precipitated out. It's hard to see there. Yeah, there it is. So there's my fluorinol. It's good yield, huh? So my fluorinol, which is, it's got a lot of organic, non-polar, but it's also got an alcohol. It's soluble in water, in methanol. It's pretty soluble in methanol, but it's not very soluble in water. And it's not very soluble in, you know, about, let's see, 4 milliliters of methanol. It's about 4.5, 5 to 1 methanol to water. It's not soluble in that either. Okay, so I precipitated out my product and I'm gonna be able to filter it to isolate it. But before I do that, I wanna do a quick kind of purification of it, a crystallization. So I'm gonna heat this solution up to near boiling and see if it'll dissolve that precipitated fluorinol. And then I'll cool it slowly so it crystallizes slowly. Because when it precipitated fast just now, it probably trapped a lot of impurities. So let's go ahead and turn our heat on a little bit. And I'll watch this carefully because I don't want to step away and have it start boiling and evaporate all my solvent away. And then when the solvent's gone, the flask is no longer evaporatively cooling by the solvent. It gets super hot, the glass, and then it will burn and oxidize my product. I don't want that. So let's just be careful and wait for this to heat to a near boil. Okay, it's been heating a little while. It's not quite boiling, but it's mostly dissolved. Oh wait, it's all dissolved, huh? Yeah, I think it's all dissolved. So I think I'm going to stop there. So now what I'll do is I'll turn off my heat and I can decide, do I want it to cool on the hot plate or do I want it to cool off the hot plate a little faster? I'll have it cool on the hot plate. I'll cool it nice and slow to see if the crystals come out. Great. So the way I'll cool it even slower on the hot plate, well actually the hot plate will cool, it will cool slower, yeah, but it'll evaporate a little bit of the solvent as well. What I'll do is I'll put a beaker over the top of it. If I can get this wick out of this beaker, okay. And I'll just put this beaker over the top. And the beaker is not sealed. It's got the little lip, so there's not a vacuum. It's not going to cause a vacuum in there. But it will, the beaker will fill up with the methanol water vapor and slow the evaporation and slow the cooling due to that. Okay, let's check the iodine chamber. Open this up. Oh yep, some spots turn purple. That's interesting. It looks like the, I'll get both out. I noticed something. Sometimes when you're trying to visualize spots like this, it's nice to look through the back of the plastics. It's maybe a little bit clear at times, so that's another option. So let's go back here so you can see the iodine's showing us some new stuff. Actually, I don't know what this does. Okay, so the iodine's showing some new stuff. I see on the baseline there's some material there that wasn't showing up under ultraviolet. There was something that never left the baseline, didn't show up under UV that I saw. Maybe I missed it, but I didn't think I see it. The fluorinol, which is here, looks like it absorbs the iodine strongly. Whatever this was, it was a small little impurity or something. That doesn't seem to absorb iodine. This, I'm thinking, is the fluorinone. Yeah, that should be fluorinone. Fluorinone, it looks like the fluorinone absorbs the iodide only when it's a heavy spot. I think this was our heaviest spot of fluorinone, and then these ones are fluorinone. That was running out as a reaction went on. I know I did say earlier that, oh, you have something with the same RF if one takes iodide and the other one doesn't, and they're different molecules. I'm pretty sure these are both fluorinone. It's just maybe you need a heavier spot, because actually the one at 0 seconds, the methanol fluorinone has no spot, and then the methylene chloride fluorinone has a spot. Maybe it has something to do with that, but I don't think so, because when we spot these, the methanol and the fluorinone, the methanol and the methylene chloride both evaporate quickly. And whatever this, like before I didn't mention it, but there was like some pink haze up top here that doesn't seem to absorb much of the iodine. And if I let this sit out for a while, I don't know, an hour or so, the iodine evaporates away. Not evaporates, it sublimes away. And then your TLC plate will look like it did before the iodine chamber. And you could recycle it then too. So if I want to recycle it, I can do that. I added the water to the reaction after about 15 minutes runtime. I forgot to tell you that. Remember when I added the 1 milliliter water to the methanol? While I'm waiting for crystals to form in my cooling methanol water fluorinol solution, I don't see any crystals yet, but while I'm waiting for them, I'm going to prepare a solution of 80% methanol, 20% water. The methanol, it's already wearing off Sharpie. I should use another method than this, but that's okay. Okay, 20% methanol, 20% water, 80-20 methanol water, because I'm going to use that to help transfer the crystals from the crystallization flask to the vacuum filtration setup. I'm going to filter it through vacuum like we've done before with the Buchner funnel and filter flask and the water aspirator. Okay, so let me prepare that. It's simple enough, 80-20. I think 10 milliliters will be plenty. So I will just fill up this graduated cylinder to about 8 milliliters with methanol, and then fill it all the way up to 10 with water. So simple. 8 milliliters of methanol, it's a little bit on the higher end. So I'm gonna use, instead of pipetting constantly, like I'd have to pipette like 10 times, I'll use the short stem funnel to get it close to 8 milliliters, and then I will pipette the last bit. So let me carefully, and when I'm doing this, I'm holding the short stem funnel above, so as the methanol comes down through the short stem funnel into here, gas can escape quickly, so it pours nicely. So let me add a little bit. Let's see if I can get about 6, 7, about 7 milliliters now. Okay. And my short stem funnel I just used, I don't need to go clean that in the sink because it was just rinsed with methanol. It's cleaner than it started. Okay, let's get some methanol. So I'm at about 7 milliliters. This is approximate too, this volume. Doesn't have to be very accurate. I'm just trying to make this 80-20 methanol water because I want it to be, when I transfer my crystals, I don't want it to be as, the crystals to be as soluble as they were in just straight methanol. And I don't want to just use water because then that'll precipitate out impurities along with the crystals. So 80-20 water, it's kind of in between, and should work good. And so I've got my methanol in there first, 8 milliliters. Now I just add water, DI water, to 10 milliliters. And I think I'm good. Oh, a little bit of drop more. Is that good? Yeah. I think that's pretty good. What do you think? It's bubbling a little bit, huh? Whenever you mix solvents, it's exothermic. Generate a little heat. My goodness, this will not focus, will it? There it is. So it's at about 10 milliliters. Looks good. The meniscus about 10. And I will pour this into my Erlenmeyer that I've labeled 80-20 methanol water. And I'm also going to make this cold. I'll cool it in a beaker that's slightly larger than this. Okay, so this beaker is too small, but this beaker, that'll be a good size. It'll fit in here, but it shouldn't be too big. It can't really fall over, right? That's what I want. And now I'm going to put some ice water in this. I've got a little ice in there, not too much. And if I add water, it will wind up cooling my solution faster because it'll have more surface contact with the flask. Okay, just got a little ice water, not too much. Put my Erlenmeyer in there, so now it can't fall over, and it's being cooled down nice. So when I'm vacuum filtering, I'll have cold 80-20 methanol water to transfer my crystals and to wash the mother liquor off of them. I still don't have any crystals yet. I'm getting a little impatient, so I'll go ahead and take off the beaker and remove this, which is still kind of warm. I'm gonna let it cool a little bit faster on a wood block. We'll see how that goes. Oh yeah, I'll set up the cool time-lapse video. This crystallization is really taking its time. I'm going to see if I can speed it up a little bit. It looks like it's crystallizing out the fluorinone more than the fluorinol. Let me see, I just moved it a little bit. And I'm seeing yellow crystals. I want white crystals. Interesting. Maybe I'm just seeing the white crystals as if they're yellow. Oh, look at that. There it goes. Sweet, sweet, sweet. As I disturbed it, it just started going. Cool. This is live, real time. So this happens sometimes when you crystallize something. If it's not going and you disturb it a little bit, it initiates the crystallization quickly. So this is maybe quicker than we want, but it's cool to see it in live this fast. So I'll let it finish crystallizing and then I'll filter it. It'll still be more pure than when it precipitated out initially. Time to vacuum filter these fluorinol crystals. They look a little bit yellow, right? But we'll see if after I filter it for yellow. And it looks like it's pretty much just saturated. Looks like there's no solvent in there. What I'll do to help with that is I'll break up those crystals a little bit, with a spatula. Yeah, it's got some liquid in there still. I still want liquid in there because if I don't have liquid, then I don't have anything for my impurities to dissolve in. I need mother liquor for the impurities to dissolve in, and they can be filtered away. And here's our filtration setup. Got my Buchner funnel, my filter flask, and I cut out a circle that will fit this Buchner funnel well. Push it down in there good. Let's see how I'm doing. Yes, it's a little bigger than it needs to be, but I think it's going to be fine. Push it down, and then I'm going to use some my cold solvent. It's 80% methanol, 20% water to suck it down. But first, let's see how it's going to get suction. I got my water trap bottle, and then over to my water aspirator. So let's turn that on, full blast. Splash guard's doing a good job, not splashing up on the counter. And I'll come over here and I'll check my vacuum. I'll palm over. Oh, it's sucking good. I can feel it. Yep, it's got good suction. So I'll wet down the filter paper with a little bit of this 80-20 methanol water. It's going to suck the filter paper down on the holes in the Buchner funnel so that I won't have as much crystals kind of escape around on the outside. Okay, giving you a nice bird's eye view of me trying to get these. Oh, I got a little bit of something on my filter paper, huh? See, I'll use a different spatula, see if I can get that out. I don't know what that was. Oh, I know what that is. It's a little piece of green paint came off of my ring stand that's holding the phone. I used the ring stand to make Michaela's leprechaun trap in elementary school. We painted it green. Okay, so I've got this solid in here, and it's not really a solution, so I'm going to kind of scoop it out and then like tap it down. Let's see if we can get it to drop. There we go. I'll try to get most of it out. I believe this fluorinol is kind of a cottony solid after it crystallizes. So yeah, that's what it kind of looks like. Yellow cotton candy right now, yellowish. But I believe when we wash off those crystals, wash some other liquor off them, it's going to be white. So let's try it. So I'm going to take some of my 80-20 methanol, put that in my flask. I'll put a couple squirts in there and I'll observe and see if it looks like it's dissolving the solid very quickly, then I'll be careful with it. I won't add too much. No, it looks pretty good. Can you see through there? Yeah. So I'll swirl that around, dump it on my crystals. Try to get just about all of that solid out. It seems as though it's working good, just the 80-20 mix. It seems like it's transferring the solid well, but it's not dissolving it too much. Pour some more. I'm going to spread it out a little bit too on here. So if I spread it out, it'll dry faster. And then I'm going to take some more 80-20 methanol. Rinse that on there. So it's got a little yellow haze to it. So I would say this isn't 100% pure, because the 100% pure fluorinol would be white. And the fluorinone we started with was yellow, so this is just a little bit impure, but I bet it's pretty pure. Yeah, and I'm able to wash this mother liquor a lot because it's not very soluble in the 80/20, so that looks pretty good. So now I'll let that sit under vacuum, the water aspirator vacuum, for about, I don't know, a minute, a couple minutes. I don't like to waste too much tap water. And then after I let it sit there for a little bit, I'll take this out and let it air dry, and then I'll characterize a little bit. Maybe we'll do an IR, and what the heck, maybe we'll do an NMR as well. As I'm vacuum filtering this, the mother liquor below, it's got solid in it, so it looks like some of the fluorinol did come through. As always, you always get a little bit of your desired product dissolved in the mother liquor, and I think it is the fluorinol, not the fluorinone, because it's whitish, right? It's more white. So if I wanted, I can filter this again, get a second crop, but I'm gonna be fine with this. I'm just gonna see what this turns out to be. Now I'll take my crystals off the vacuum filtration. So should I keep this here and just turn off the water aspirator? No, break the vacuum first. So easy enough. Just remove that, set it down. Now the vacuum is broken. I can even go a little further. So I can see a little bit of my fluorinol in here. If I was being really careful, I would recover that, but nope, I'm just doing this quick and dirty. And I can turn off my water aspirator now. I'll carefully grab my filter paper out, put it here. It'll dry faster than when it's in here. And I'll give it maybe a half hour or so here to dry, and then I'll get the mass of it, take an IR, take some NMRs. So my mother liquor has quite a bit of fluorinol in it. I could, like I said, refilter it, but I'm not. I've got enough over here that's drying for the characterization I want to do. And but I want to clean up while I'm letting that air dry. Let's get my Buchner funnel bottom here and give it a little acetone rinse, because this is fluorinol. It's organic. Acetone should dissolve it, and it shouldn't go down the sink drain. So I'll rinse out the fluorinol into the mother liquor, and the mother liquor will start dissolving with the acetone. And actually, I'll do this to get the residual fluorinol out of this as well. I could have done this first time. And then I will take this over to the fume hood and rinse it into the waste bottle. I have a little solid that dripped along the outside. I'm going to need to set the phone down, and I'll rinse that into the waste container with acetone as well. The fluorinol has been drying for about an hour, so I'm going to transfer it now to a watch glass. I'll first weigh this watch glass empty and then get the mass of the crystals. So first I'll zero the balance pan to get the mass of this watch glass. So 25.730, with that. Okay, so now let me take this out. Carefully scrape my fluorinol off of the filter paper onto the pre-weighed watch glass. Here we go. Ooh, it's a little bit sticky. It's still maybe a little wet. Yeah, I should air dry it longer, but I want to finish this experiment up and get it to you sooner, so that's okay. Still have a little bit on the filter paper too, so we lost a little yield there, but that's okay. Let's see what our wet, slightly maybe wet fluorinol looks like in terms of mass. So 25.7977. I wonder if it'll keep going down, like it keeps evaporating moisture. Yeah, it's still going down. Let's go with that. 25.7974.